All right, and just to make sure, can everyone see my desktop at the moment? Perfect, cool. So let's get started then. Let me, cool. I can still see the chat. All right, so welcome to Data 608, Knowledge and Visual Analytics. To introduce myself, I'm Charlie Ferrari, adjunct instructor here. I currently work at Plotly. I'm a solutions engineer there, which ends up fitting really nicely with what we're teaching in this class. So we will be using Plotly in some of the modules that we're working with, and it's a really cool visualization library. Has anyone come across it or have used it in the past? Cool, cool. So hopefully you guys will find that interesting. And obviously we'll be using tons of other um, packages as well in sort of surveying the data science, data visualization landscape. And just a few other things here. I have sort of a side interest in cities and like using a lot of the sort of the data science ecosystem out there, the sort of new visualization tools to work on interesting projects using open city data. This is actually looking at if anyone's ever come across the shared taxi cab data, which it's a pretty interesting data set. You could basically for any taxi trip, you're able to get anonymized, start and end points. So this is sort of looking at if there's cab share um, happening informally using this data. So you could kind of see in this pattern here along that's 108th Street in Forest Hills. That was sort of what inspired this. So you're able to see that across the city. And then in my previous life, I was working with sort of economic data and economic forecasting tools. So eViews, if anyone has come across that, or IHS, Global Insight previously, and now after I had left IHS Market. So this class, just to really summarize what it's about, this is really meant to be about presenting information, um, basically dovetailing with a lot of the other courses you've been taking in the data science masters. So, really, this is going to focus on communication and on, really sort of that aspect of data science. But we will be using, in terms of technology, it'll be a lot of similar tools that you guys are using in other courses. So R and Python will start out in, and then given just the nature of data visualization, in a lot of ways, I sort of see it as a sort of junction between data science and web development. So we'll be going into some more interactive packages, Shiny in R and Dash in Python, and then sort of moving on to D3 JS and trying to get some of the basics of JavaScript. So that should sort of round out the sort of more web development side of data visualization. In terms of general class info, all class dates, they will be in the syllabus. Uh, we were switching around the days at the last minute when the meetups would be, and I'm just going to finalize that shortly. But in general, every other week, homework will be due. The first homework is due on September 9th. And I just want to work out the pacing of everything. We actually usually in these classes, if you've and I imagine most of you have taken or almost all of you have taken, this is in your first semester, there's usually holidays that sort of have classes that are missed. So I may try to fit in potentially sort of shorter project to fill in some of that time. But I'll sort of get back to you in terms of the pacing. But in general, each homework, it's associated with a module. Each module is it's meant to be every other week, and I'll either sort of allocate some extra time for final projects, or sort of work out the timing in another way. So you have your modules that are your homeworks, and at the end of the semester, you'll complete a larger public project. And in terms of other info, everything is going to be on Blackboard. The announcements are, you can pretty much consider that sort of the record of the class. And I just, it's a good idea to sort of keep everything centralized there. But we do have a GitHub page. So the assignments, they're all hosted there. And that just makes it easier for you guys to sort of work with it in a more GitHub style workflow. And then the only other issue is discussions, which will happen weekly, and those are just also in Blackboard. And then just in terms of GitHub, like, we will be using that pretty heavily. I would prefer it if you guys submit assignments using GitHub. You may have some issues with, like, we have for module 2, we'll be working with a very large data set. So we're sort of working with visualizing big data, and you won't be able to host the whole thing, but it'll still be sort of based around GitHub. And and then one more thing to note about projects is this will become more of an issue as we move into Shiny, Dash, and JavaScript. But for these more interactive platforms, when it is possible, I would require that these must be deployed. For Shiny, it's very straightforward. So you're able to just deploy that using Shiny apps. With Dash, I made it optional because it's a bit more sophisticated. But I would prefer it if you guys host it there. And then for JavaScript, we'll be using GitHub pages for that. And I'll talk more in later meetups about deploying these, but this is just sort of the way that the projects will be, or that those projects will be submitted, rather than sort of a repo that that may not run on other environments. Deployment just really helps make sure that it's running in a general environment. And then with other projects, like the first couple of assignments, I just like you guys to keep in mind that as I'm grading these, I'm running them on another machine. So things like keep relative file paths, which is really the easiest way to make sure things are running properly, or just simply bring in data directly from where it's hosted on the web. A lot of times you'll be able to do that. So getting started with this first lecture, we'll just go through a few sort of theoretical, some theoretical background of data visualization. The main focus of the course, it's going to be very practical based, so it's very heavily leaning on the projects. The discussions are going to be really building on what we're talking about in this first lecture. So what I'll actually be doing is I'll be going through, and we'll talk about Edward Tufte. He's really one of the pioneers of data visualization as a field. And I like to focus the discussions around concepts of his, which are really geared more towards static visualizations, and try to adopt them to more interactive visualizations. So the sorts of visualizations that are enabled using the tools that you guys are learning. And I see some questions here. So the book recommendations, I'll include some links, but these are meant to be more. Shunhui asked if there are any book recommendations. There's nothing required, but I'll post some recommendations, and don't worry if you're not able to get a hold of them. And one thing I would recommend is in this lecture, I'll be talking about a few authors, and just sort of look up what's out there on the web. A lot of these people are pretty well known, and there's a lot either content written by them online or sort of what other people have written. And then Mehdi asked about libraries in Python. So we're not going to be using tools such as Tableau and MSBI. These are very useful tools, but I really want to keep it ingrained in sort of our libraries, Python libraries, and more like lower level visualization packages. And so in terms of these software packages, we won't be covering them. And for the final project, where you do have some leeway in terms of what technology you're using, we won't be using Tableau or MSBI for that. So we're focusing on sort of our Python JavaScript-based technologies. For Vikas asked for art projects. For art projects, either would be fine. RPubs are a really smooth way to sort of submit these. So so if you know how to, if you're familiar with that, I would use that. But there's more leeway in terms of the art projects. And then Shunhui asked again about sort of any suggestion in prepping for the more kind of web development oriented packages. I'll address that. I'll address that a bit in the slides here. And yeah, there are some other suggestions there. Yeah, and JavaScript is something that this is really the only course in the program that touches on JavaScript, and it's pretty different from what you'll be used to in R and Python. It's definitely worth it in my opinion. If you are able to get a handle on D3, you'll feel like a wizard. But it is definitely challenging. And in terms of JavaScript, like I'll be peppering just general content about some basics of web development throughout the course. Worrying but exciting, Shunhui. So with that, let's get started with some techniques and theory here. So does anyone recognize this photo and what it might be referring to? Yep, Joel mentioned it's a space shuttle. Joel mentioned it's the Challenger. And yeah, this happened in the 80s. So people who are older may have more direct memories of it. And yep, John, this is about the O-ring failure. So that was what ended up happening to cause this disaster. So here, this is a picture where you could kind of see what's happening. There are these things called O-rings, which are around the rockets that propel the shuttle, and one of them sprung a leak. You could see the fuel, and that ended up igniting with the sort of fire underneath, and that's what ended up causing the disaster. And so this is and this example actually is from Tufte's book. I believe it's visualizing quantitative information, visual explanations, and and this is what the engineers were going off of in terms of tests for these O-rings. So there were this was all properly tested, and this is the record of what was happening. So on each of these, this is meant to be sort of more skeuomorphic, so you could see the temperatures on the rockets themselves, and sort of see a mapping of where the failure is happening during these tests. And so just based off of what you're seeing here, is anyone able to see a pattern of what might be happening? Like if you were to sort of, try to find out what this is trying to communicate, does anyone have any ideas of what might be happening? Yeah. Yeah, so Dan, you are right that it was the cold, and but the thing is, looking at a visualization like this, it's less clear what the pattern really is. You could all the information is there. This includes all of the tests that were available, and it's not like there's wrong information in this visualization, but just simply looking at it, you're not really able to see that it's cooler temperatures that are causing failures. So you could kind of see, there's a 57 degree, and I think it's the black means two failures. You can see 57 here, 53 degrees there was a failure. You have all of these records where there weren't failures. So if you try really hard, you could get the pattern, but it's pretty difficult to really get at that intuitively. And Tufte proposes another way of visualizing this. So this is the exact same data that you're seeing over here. So this is the O-ring damage index. So these refer to where the O-ring is located as measured on the fuselage. And here you're able to get a clearer idea of what's happening. And this is important because it's something that it's more of a visual pattern than anything else. If you were to run a regression of what of temperature and O-ring damage, you have a lot of it's sort of overweighted towards warmer days, and it makes sense. This is in Cape Canaveral in Florida, and you wouldn't really get this in using a regression or another technique, sort of analyzing data in that way. But visually, you begin to see that you have a lot of cases where there are no issues, but those drop off once you get below 65 degrees, and you could see how you end up with more damage as the temperatures decrease. And it was an unusually cool day on the launch day, so that ended up being looking at this information presented this way, it's a lot clearer that perhaps it would have been a good idea to not have the launch on that day. And obviously, that's not the only example of bad visualizations. Here, you could see quite a few bad ones. Like looking at this bar chart as an example, can anyone tell me what might be happening there? Like why it might be misleading or why it's considered a bad visualization? Yep, exactly. Brian mentioned that it's a funky y-axis, and when you are looking at a bar chart, you want you want sort of a zero axis to make sure that you're comparing these quantities in the correct way. So you have a bar that's looks twice as high as all of the others, but in reality, you're looking at a difference of of a degree. So it's the warming trend is there, but it's not like temperatures. Things would be a lot different if temperatures ended up doubling. And then you have just a lot of other examples here. So anything from just simply not giving consideration to the amount of noise in a visualization, to not even bothering to have your percentages add up to 100, to not really having proper labeling, or really sort of letting form take over for function in a data visualization when you're looking at EV usage. And Tufte really, these are his main goals, the way that he classifies the main goals of data visualization. So, really what you're doing is minimizing mental effort, making information easy to retain, and making it about insight over beauty. So you could see some descriptions for each of these, but really it's meant to be sort of a shortcut to understanding data. It's obviously much easier to look at a visualization than to look at a unformatted table to get to sort of get the point of what you're trying to show. And it has these effects in terms of memory. And these are sort of the major strategies that Tufte goes through. We'll be actually going through each of these along with a few others that he mentions individually in the discussions. But these, I would say, are really the big ones. Just mapping data to purpose. The information to ink ratio. What that actually is basically a way of saying, like, be concise with your visualizations. So one thing I would recommend as you're building visualizations for this class is one way to sort of maximize this ratio is to think about what you're communicating, and try to pare away as much as possible without losing the meaning of it. And then principle of small multiples, which I'll get into in a bit, is really sort of about a strategy for comparing different values. So in terms of thinking about data and purpose, and with this, we're getting more into a few slides from Tamara Munzner. I'll add this link to, actually this link should be in GitHub already, but she sort of gets into more sort of kind of the specifics of how the brain understands visual stimuli, other stimuli, and how that really affects understanding in terms of data visualization. And you've probably seen different classifications of data in this way. So looking at you could think of things as relational, spatial, or tabular. Relational and spatial, these are sort of two major categories that are very different from more common tabular data. Spatial is pretty straightforward. It's maps. So geographic data, it's really based off of an intrinsic position. So there's there's sort of a very sort of specific thing that you're referring to, and maps really work to sort of display that information. Relational concerns different links between points. So you could think of things like family trees, international trade, looking at bilateral trade relationships. And this, actually, what I'm showing you right now, this is relational. So we're looking at sort of different hierarchical relationships in this way. And when you get to tabular data, you have a lot more variety, and you're going to be seeing a lot of this sort of data. So you could look at either ordered or categorical data. And then within ordered, it's meant to be divided into either discrete or continuous. So, the way that you're able to, sort of divide these data, like you'll usually be able to see this within the table. So, categorical, there's not really a concept of order. It's really just, different discrete, distinct categories. You could look at things like discrete data where order matters, but it's almost hybrid between continuous and categorical. And then continuous data, that's sort of your numeric values. So in terms of the best ways to sort of display these sorts of data, spatial data is the easiest because maps are really the way to go. You're sort of looking at something physical, and maps are just simply a representation, a direct representation of that. For relational data, and Munzner bases this off of quantitative research, like really sort of understanding how you're seeing these different sorts of ways of displaying data. So this is meant to be very broad. We're not really talking about specific visualization types. But you could obviously kind of map these to visualization types. So looking at something like contain, does anyone have an idea of what sort of visualization might that might be an example of that? It's a bit tricky, and keep in mind you are talking about relations between data. That might help in terms of different examples of what you might be looking at. Yep. So yeah, Mehdi, not tree. That would be more connect. But Dan, in terms of talking about sets. By the way, my headphones just ran out of batteries. Can everyone still hear me? Perfect. Okay. So yeah, for trees, that's more the connect strategy. And who was it that mentioned? Dan. So sets, you're on the right track in terms of what this is referring to. And one way of visualizing sets is by using Venn diagrams. So, a Venn diagram, it's kind of a version of this where you could think of, sort of a field of possibilities, and you're looking at the intersection between sets. That's what a Venn diagram is usually showing. And then, with other sorts of strategies here, you could kind of relate them to existing visualization types. So looking at more traditional sort of tabular data, or more common tabular data, you could relate things like position. That's things like scatter plots, length. That's more like bar charts, area. You could sort of look at sort of size within a bubble chart, perhaps, etc. And these are ranked in order of how sort of important they are. So when you are looking at ordered data, position is the best way to go, length is second, area is third, etc. And these are good things to really think of when you are looking to choose visualization types. So as an example, when we're looking at length versus area, you could look at this very directly when comparing something like a bar chart to a pie chart. And this is actually something that is, you'll notice when pie charts end up having way too many categories, is you'll see a lot of small slices, but you're not able to properly parse, is this slice twice as much as this slice, for example. Whereas with length, it's very easy to see, it's very easy to see with these lines that this line is, a little bit less than twice as long as this line. With position as well, you're able to measure their relative position with relative ease. But if you're comparing these two squares, you're not like you don't. And this is just human mind in general. Doesn't have a good intuition of is this square a quarter of the size of the bigger square, half, etc. So trying to put that into practical, sort of in a more practical mode, I sort of just quickly went to the next slide. I'll just quickly do it again. So just based off of that quick, look at the graph, does anyone like what sorts of ideas do you guys have of what it was showing? Perhaps like anything that you could possibly glean from sort of a second of looking at it. S&P 500, good guess. It's actually not that, but and more vaguely, just what stuck out to you with that graph? Okay, so a curve. I was looking down, Dan. So there were two curves. They were Abina, you noticed that they were different colors. Um, you're able to that's sort of using color, also using position because those were different measures. Um, Brian noticed that it was a curve, so you're able to see that it's not a straight line going up, a straight line going down. But there's sort of some general curve going on. So what this actually was housing prices, just a graph grabbed from The Economist, and this is really really well done in terms of like mapping what's most important. So most important are the prices themselves. That's a that's let me go back. Oh, and I don't have that for. So categorical, you could see sort of the position there. Most important is the housing prices. That's being shown by position. Next is time. So most people saw, like if you saw a curve, probably if I were to ask some more questions, some people would guess that there's changes happening over time. Joel guessed that it was the S&P 500, looking at that over time. So, that was something that was very apparent. No one ended up mentioning, and obviously I showed it too quickly to really, get to get an idea of what was there. But it's less important what the city was. So, that wasn't immediately visually apparent, but it was really getting the important points across using similar strategies to what we saw earlier. And for a few of these examples, I like sort of mapping this out to ggplot. One of the themes, like as we're delving deeper into the technology, is going to be sort of comparing really the philosophy behind all of these graphing packages. And ggplot, it's very much driven by the data. And like the GG, it stands for the grammar of graphics. It's meant to really, have a more intuitive, a more intuitive way of mapping the data to the visualization. So, all you're really doing is, setting X, Y, and color, and you guys could imagine that this is coming from a tabular data frame. You have sort of three columns, let's say. You have, just your year, your price, and what city the measure is associated with. And, using sort of a grammar-based graphing package, you're able to just simply point to those measures, say, I want my x-axis to be year, I want my y-axis to be price, and I want to color my data by city. The next strategy in terms of visualizing data is maximizing the information to ink ratio. And really what this is meant to do is, as I mentioned before, just look at your visualization and try to look at the different aspects of it. So if you sort of just plot something default, a lot of times you'll see things like tick marks, perhaps extraneous labels and grid lines. And a lot of times, what Tufte really recommends is try to keep things as concise as possible without really removing the sort of main point of the visualization. So you're still getting the point across without having, in these cases, grid lines or even fully drawn axes. So taken to its logical endpoint, you have what are called spark lines. And these are really meant to be very bare bones. And a lot of times you'll see these sorts of spark lines by taking away a lot of distracting elements. It makes comparison a lot better. So looking at small multiples of spark lines, you're able to more clearly compare what you're looking at. So this is looking at stock data over time, and the stock prices. You're not really meant. It's less important what the absolute price is. It's more important what the behavior of the prices is. And small multiples is a way of sort of separating out the absolute price by and really getting a handle on the behavior. So you're able to see broad trends. You're able to see the decline, sort of a rough decline and increase with a lot of these stocks. So you can sort of see that general pattern, as well as obviously what's making these companies different from each other. And again, looking at this in terms of the grammar of graphics, ggplot deals with this, by looking at facet wrap as another sort of variable. So ggplot, the way to think of it is you have your variables in your data frame, and you're simply mapping them to these different strategies. So before we were mapping color to the city, like that's how we were dividing things, but we could just as easily have looked at all of these in a small multiple style, and we could make that city in this case facet wrap, but ggplot refers to these as facets. But really I'm just highlighting some of the syntax to kind of highlight that ggplot is sort of more grammar based and based off of these variables. So this is getting into another sort of more modern thinker in data visualization, Scott Baronato. And the way he, so this was just one example of how he sort of deals with comparisons. Usually dual y-axes, dual y-axes aren't the best way to deal with sort of viewing data. Small multiples gets rid of the need for that by having separate axes in separate subplots. But sort of combining it in this way is usually not best practice. But one strategy is making sure that your measures are comparable. So looking at gold and silver prices, you have a similar problem to looking at stock prices, where the absolute measure matters worse, doesn't matter as much as the relative behavior. So looking at an index, looking at price changes is really a better way of finding out what's happening. So you don't even see this in the dual y-axes, but looking at percentage changes, you see that silver prices are more volatile than gold prices. So you see a lot of similar patterns, but the peak is higher with silver and the trough is lower with silver. In practice, small multiples, as I mentioned before, you see this a lot with spark lines. And these are just a few examples of how this could really make information clearer. As an example, looking at the spark lines on the lower left, looking at these various funds. Can anyone point out sort of what the outlier is with these funds? So if you were to, if you were to pick the one that's different than the other, which one would you pick? Right, Peter mentioned PIMCO. That's absolutely correct. And that's actually a bond index, whereas the others are concentrated in equities. But spark lines really allow you to see that pretty apparently. It doesn't. You're able to see similar patterns, and you see the pattern that's different. So this is getting back into Scott Baronato and the sorts of strategies he focuses on. And I like to sort of think of his take on visualization as reframing a lot of what Tufte talks about. So really he talks about it in terms of the point that you're trying to get across. So he's focusing on the communication aspect of data visualization. At its core, data visualization is really about communication. And I think of this as really the conceptual version of maximizing the information to ink ratio. And then you can sort of see a good rule of thumb in terms of how to judge a successful visualization. So as an example, this is text that's explaining different differences in income between rural and urban America. And this text, all the numbers are there, but you have to read through it in order to really get the sort of get the point that is trying to be communicated. So this text is pretty much directly translated in this visualization. All the relevant points are there. You're able to see things like relative populations. So you could see that displayed at the bottom. And this is even sort of getting even more bare bones than spark lines, where with spark lines you're still preserving information about the trend, but in a lot of cases you're really just looking at a one-to-one comparison. You're looking at from 2014 to 2015, did things grow or decline, and by how much? And looking at things with just these 2-point spark lines is an even more bare bones way of displaying this information. But you're able to really clearly see what's happening in a lot less time than it takes to read this whole paragraph. And in focusing on communication, he highlights a few sort of things that Tufte doesn't get too much into when he's talking about data visualization. So one of the things that he focuses on is really this communication aspect. So here we have a graph of vinyl sales since 1993, and the point I'm looking to communicate with something like this is this is hipsters just driving vinyl sales to unprecedented levels. And we'll put a pin in this for a second, but I want to sort of get into how this applies to, sort of communication applies to other examples. So this is sort of a similar way, similar tangent to what we were doing before. Don't try reading all of this, but this is basically a Trump talk from earlier this year. He was talking at Davos and talking about the relative success of the economy under him versus Obama. So you could see, if there are relevant numbers referenced. Obviously it's hard to follow, but there are specific stats that he's talking about. So he's looking at GDP, in the quarters that he was president, and comparing them to the to what was happening under Obama. So what I ended up doing was just taking the snapshot that he was looking at. In this case, he's looking at specific sort of looking at specific quarters. What? Can anyone hear me? Okay. Okay, sorry, Jan. It might be on your side, so there will be a recording of this, but at least the recording's fine. So, sort of distilling, the raw numbers that he mentioned. This is just a bar graph of quarterly GDP growth. So, the main message that he's looking to communicate is the economy is doing better under Trump than it was under Obama. And the sorts of stuff that you would look at when you hear a politician say something is is this a lie? Is this the truth? And sort of what sorts of things would you analyze? So I definitely don't mean this in a post-truth sort of way, but you need to think about like what specifically you're asking. So if you're trying to analyze what you're hearing on the news, you could ask, are the numbers wrong? In this case, they're not. Has this been a long recovery? It still is. It's on track to, it's the second longest so far, and it's on track to be the longest. Were we going in the wrong direction for the first two quarters he referenced? We were. If you look at the visualization, that's not the direction we want to be going in. So he was factually correct when he's talking about those quarters. So looking at just these questions that we're asking, these are all true statements. But what's more important is really trying to put all of this into context. So all I did was I took a screenshot of this larger graph, and this really puts GDP growth in perspective. So recently, actually, if you've been reading economic news, you've probably been hearing about the most recent GDP quarterly growth. It was pretty high at 4.1 and then revised to 4.2%. But looking at a graph like this, you could see that it's not super out of the ordinary. It's a bit out of the ordinary looking at, it's definitely, on the higher end of things, but it's, looking at sort of just, an intuition of what the variance is of GDP growth during this recovery. 4% growth isn't super abnormal. So what Trump is literally saying is economic growth in Q4 2016 and Q1 2017 was lower than Q2, Q3, and Q4 of 2017. But what Trump is silently allowing his listeners to imply is that really sort of allowing listeners to draw their own conclusions based off of this. So Q4 2016 and Q1 2017, this is meant to be a stand-in to the horrible Obama economy. The quarters that we have in 2017, that's meant to be the growth that I'm bringing, and that's the growth that I will continue to bring. So this is a bit more insidious than a lie. It's not, these are sort of carefully framed statements. And, it's framed with the idea of, listeners are going to hear this. These, a lot of times they are factual statements, but it's, really sort of communicated with sort of the idea that listeners are going to imply something about what you're saying. So one good rule of thumb in sort of evaluating fake news, evaluating what you're hearing on the news, is to really expand your context. First, be aware of the context, but expand it, and see if anything changes once you do that. And just to sort of show that this isn't a new phenomenon, this is a graph that was it was pretty popular in the economics blogosphere during the early recovery. Um, so what this is looking at is job growth over the sort of early, the sort of late recession and early recovery. So looking at this graph, can anyone pinpoint where jobs started growing again? '09? And when in '09? So we got, yeah, we got a few dates here. So yeah, a lot of you guys picked up on what was happening here. So the what this is actually looking at is job growth, and you know, anything below zero that represents uh, losing jobs, and you know, and really what this is looking at is the what it's sort of presenting is the you know, change of rate of job growth. So you know, what a lot of people see is, you know, you see the red Bush years, you see the blue Obama years, you see things going down, you see things when they're red, you see things going up when they're blue, and you know, while certainly it's a true statement that the rate of job decline was falling under Obama, it's yeah, and as Dan mentioned, compared to population change, still wasn't great. But you know, really, it's you know, this is a graph that, you know, it tells a really great story, but you know, it's you need to really sort of focus on what it's actually telling. So going back here to what I said about vinyl sales, um, what do we think about my point here? Yep, and Wen mentioned before, it depends on how you phrase the question. That's absolutely right. You know, data, and that's you know, really the way that Scott Bernardo is thinking of data visualization is that, you know, you have a something that you're looking to communicate, and you know, that's going to you know, drive what you're visualizing. So you know, using this as an example, I'm trying to make a point about hipsters and vinyl sales, but in reality, it's fake news because if you look at vinyl sales over a longer time period, you know, it's really a drop in the bucket in terms of, you know, where vinyl sales were in the '70s, when that was how that was the best way to consume music. So is there an uptick? There's absolutely an uptick. You know, you could blame it on hipsters, but it's nothing compared to what vinyl sales used to be. So it's not like now is the time to invest in vinyl. Um, and you know, this is just sort of a funny way of, you know, sort of the point of, you know, how you're looking at these things, where a lot of economics, in this case sports, also, you know, you know, humans want to build narratives about data, and you know, a lot of times, well, it is a weighted random number generator. Um, so a few, and we're running out of time a bit, so I'll just, and we're towards the end here, so a few more things to keep in mind. This is actually going back to Munzner, and is you know, meant to really show how, like, sort of more quantitatively, how the human mind responds to various stimuli. So I mentioned before that you know, when you're comparing things like bar charts and area and pie charts, you know, humans aren't as good at noticing relative area as they are at noticing relative length. And so looking at this, you know, really what's important is the slope of the line. So with, you know, and you're looking at the perceived sensation versus the actual intensity. You know, so with length, there's a one-to-one correspondence. So if, you know, something is perceived as twice as long as something else, that's actually what's happening. The brain is pretty good at noticing length. With area, there's a predictable 0.7 scale. So something that is 0.7 times the size of something else will be perceived as 2 times the size of the of what the other object is. And yeah, on the other hand, electrical current, probably don't want to be using that in your final projects, but it's perceived, it's a lot greater than what the actual intensity is. And this also gets into things like brightness. So when you are looking at that's not the best way to sort of directly map your data if you're just simply looking at brightness. And then just a few sort of points to keep in mind in terms of discrimination. This is really in a few of the, or in one of the bad visualizations we saw before. We had too much noise in the graph. You weren't able to sort of distinguish from the from different lines. These are sort of so that's sort of where the rule of 4 overlapping lines comes in, and these are really meant to be rules of thumb. And depending on your on the visualization that you're working on, it's not meant to be hard and fast. One example, things like overlapping lines as an example. If you have maybe 10 things that you're comparing, but there's you're sort of making the comparison that one thing is different than 9 others. It would probably make sense. It wouldn't be that bad to use lines when that's really the take-home point. Same thing for pie charts, where if you're looking at if you're looking at sort of larger categories and you're comparing them to smaller categories, or you more likely you have a bunch of small categories that you're comparing to one sort of overwhelming larger category. It would be fine to have more categories if that's really the take-home point for a pie chart. And sorry, I meant to delete that. So just to end things, this is really a surprisingly complex topic. So something that seems fairly small, but there's a lot that you could end up digging into. So I'll quickly move on to homework 1, but before I do, just based off of the content, any questions or comments on what I've gone through so far? Cool. And I'll keep track of the chat, so if anyone's typing, I'll address questions there. Here, this is just a few, just some further reading. So Edward Tufte, he's really, sort of the most famous name in visualization, I would say. Jacques Bartin is another sort of more classic visualization pioneer. I mentioned Tamara Munzner, as well as Mike Bostock. He's the creator of the D3 library. And Scott Barnotto, he actually he does data visualization for the Harvard Business Review, and his recent book was sort of a guide for data visualization, going through a lot of the concepts I mentioned of his. In terms of the standard of the homework, Chinmay, if there's anything more specific, like that's, like it's, like the questions, they're meant to really, it's meant to replicate sort of the sorts of situations that, one would come across, in your career. So, sort of a, business related question, and, sort of asking questions based off of them. So part of, a large part of the assignment is about sort of trying to work out what you're communicating with the data. So if you are sort of trying to think like what sort of visualization type you need if you want to display sort of an aggregation versus a distribution as an example. Sort of thoughts on what you might use for there. In terms of examples, I'll think about if there are sort of more good examples that like I was going to want to use sort of examples of old homeworks, but but I'll think about what might be useful there. And Mehdi, in terms of using your own data, the assignments are going to be based off of provided data sets. So part of it is going to, really it's going to be questions asked of a specific type of data. So for the assignments, you won't be able to use your own data, but for the final project, this is fully self-directed. So you guys will be finding your own data set, sort of asking your own questions of the data, and creating an interactive visualization that sort of displays and communicates the points that you wish to communicate with the data. So for that, you will be able to use your own data. For assignment 1, we'll be using this is a 2013 list of of 5,000 top companies, this will and you'll see the questions in GitHub. Let me get out of this and get to. So the GitHub repo, it's just at my account, cuny_data_608. Module 1 is going to be the assignment. So you could see. So actually, this is meant like I have this as an R Markdown document. So just use this as your template, and there's what I'm looking for. So you could just use this as your template. Like it includes some basic summaries of the data, and then sort of looking at both of the questions. So we have different stats of these companies by state, and you could see in these questions we're addressing a few things. So we're looking at how many company, we're looking at the distribution of companies in this data set by state. So just looking at how many are in each state, and there are some other specifics about which axis we should use. So in particular, for question 1, this is assumed to be consumed on a tablet, so a more portrait-oriented screen. So that's meant to sort of guide a few of your visualization choices there. In terms of the Chunhui, this isn't statistics. This is mainly visualization. So if occasionally you may find it useful to include something like a best fit line, but aside from that, this is purely data visualization. So it's more on the kind of ETL side, extract, transform, load. So definitely doing operations like aggregations, though especially when we get into visualizing large data, any sort of data manipulation like that, that's all to be expected. But you won't be expected to really create a model. And then in terms of Mehdi asked, can we use Python if we want to? For the assignments, they're specific to the sort of this is meant to be sort of a survey of existing sort of data visualization landscape. So these are pretty specific to the technology itself. So the first assignment is going to be working with R. The second is going to be with Python, and then we'll move on to Shiny, Dash, and JavaScript. So my next section is starting at 7:45, so unfortunately I'm going to have to end things here. Yeah, so when for the R Markdown, feel free to use RPubs if you want, but for the first two assignments, deployment is less possible since these are more kind of ad hoc visualizations, so meant to be more geared towards the exploratory sort of work that you would be working with as a data scientist. And then as we're moving on to Shiny and Dash, we're really getting into what sorts of things you would be doing if you're creating data products for a non-data scientist. So, as a data scientist, you're able to, you could just bring your data into R or Python and do what you want in RStudio or a Jupyter notebook. But something like Dash or Shiny, that's sort of you're thinking about who is consuming this data, and how are they meant to be looking at it. And last question, Mehdi asked if it's possible to sit in for the second session. It is possible, and there's you're able to sit in for that. I would just prefer that people let me know if they plan on switching sections, because we have we're not in danger of running over our 26 user limit for the individual classes, but I just want to make sure that things don't get too imbalanced. I don't want people to get sort of kicked off if they want to attend a section. And with that, 7:45 is when the second section starts, so I think a few people are filtering in for that. So if anyone has any other questions, email is the best way to get a hold of me, or ask in the instructor discussion board. And Chunhui, the class starts at 6:30. These slides will be available. I'll upload it to GitHub. All right. Thanks a lot, everyone. So those in section 2. So yeah, if you're in section 1,